Hello, this recording is the Exam 3 review. Number 1, indicate whether the statement is true or false. 7 is an element of the set 11, 1, 2, 15. Because there's no number 7 in here, this answer is false. Number 2, write the resulting set using the listing method. The set with elements 3, 5, 6 intersected with the set 2, 9. Remember that the intersection means and. It has to come from the first set and the second set. So which ones do they have in common? Because there is nothing in common with these two sets, the answer is the empty set. Number 3, refer to the Venn diagram to the right and find the indicated number of elements. So in the Venn diagram, we have two sets. Set A has a total of 27 plus 36 elements. Set B has a total of 36 plus 24 elements. A intersect B, so what's in both set A and in set B would be 36 elements. What's not in any set at all, so out here, that would be 16 elements. So we've looked at the Venn diagram. Now let's go see what they want us to do. The number of elements in set A. So again, set A is here. So the number of elements in set A would be 27 plus 36, which is 63. Number 4, draw a Venn diagram for sets A, B, and C, and then shade the region not A and not B and C. Okay, so what does that mean? It can't be in A, and it can't be in B, and it has to be in C. So I'm going to kind of work backwards. Where's C? Well, C is right here. So it has to be, well, that's not going to show you. Let's do it this way. It has to be in C. So it has to be there. Let's do two of them at a time and see which one it might be. It has to be in C, and it can't be in A. Okay, so where's A? A is here. It can't be there. So I need to go erase the green that's also in the yellow. So let's see. I'm going to be left with this green and that green. And I'm going to erase that. So I'm going to be left with this green and that green. And I'm going to erase that green. Okay. So that's in C and not in A. Now I need to do not in B. So it can't be here. Oops. It can't be in here. Alright, so last time with my green. If it can't be in the yellow, it's going to be left right there. And the answer is going to be A. Because if I do the same thing here, it can't be where the yellow is. And it's got to be answer choice A. Number 5, use the given information to determine the number of elements in each of the 4 disjoint subsets in the following Venn diagram. Alright, it gives you that the number of elements in A is 30. The number of elements in B is 60. The number of elements in A and B is 25. and the number of elements in the universal set is 100. So right away, I know that out here, the universal set, there's 100 elements. And I'm going to work backwards. The number of elements in A and B is 25. And now I can use the number of elements in B is 60. So in B is 60, but I already have 25. So 60 minus 25 is 35. So in the disjoint sets, the A, not A, and B, so out here, there's 35. All right, now I'm going to use that the number of elements in A is 30. So here's set A. I have to have a total of 30 in that set. I already have 25, so there would be 5 more in A and not B. All right, now it wants me to find the number of elements in A and B. Well, they already told you that. It's 25. Okay. Next, they want you to find the number of elements. Oops, I'm going to put the 25 where it's supposed to go. Now they want to find the number of elements in A and not B. So over here, the answer would be 5. Next, they want you to find the number of elements in not A and B. Not A and in B is 35. And the last thing, the number of elements in not A and not B. We didn't find that. That would be out here. All right, so inside, in here, what do we have in here so far? 5 plus 25 is 30, plus 35 is 65. Now if we have 65 accounted for and we have a total of 100, we have 35 out here not accounted for. Okay, so the answer would be 35. A super duper gene company has 3 designs that can be made with short or long length. There are 5 color patterns available. How many different types of genes are available from this company? Okay, so we're going to do a design. We're going to have a length. And we're going to have a color pattern. So there were 3 designs, 2 different lengths, and 5 color patterns. 3 times 2 is 6, times 5 is 30. Number 7, use the Venn diagram below to find the number of elements in the region. They want you to find the number of elements in A union B. So it can come from A, here, or it can come from B. So A union B is what's shaded there in yellow. So how many elements will that be? That'll be 4 plus 2 plus 8 plus 3 plus 5 plus 7. And when you add all those up, you get 29. Number 8. Results of a survey of 50 students indicate that 30 like red jelly beans, 29 like green jelly beans, and 17 like both red and green jelly beans. How many of the students surveyed like only green jelly beans? So only green is going to be out here. Only green. That's what we're looking for. Okay, so what do we have? What information do we have? 50 students were surveyed. So out, let me do another color, purple. Out here will be 50. 30 like red, 29 like green, and 17 like both red and green. We want to find just the number that like green only. So we're actually looking for, we're looking for the number that like green and not red. That's what we're looking for. Okay, so let's start with the intersection, red and green. There are 17 that like both. Now, if we know that 29 like green, so here in the, let's get rid of that. There are 29 right there in the green. There's 17 already there accounted for, so we need another 12 out here. So the number in green and not red, again, we wanted this, is 12. Number 9, how many ways can a committee of 2 be selected from a club with 12 members? Okay, we've jumped over into the permutation combination section. Okay, select 2 from a club with 12 members. It does not give any titles like president and vice president. So there's no order, is not going to matter. So this is going to be a combination since order does not matter. Remember, just a side over here on the side, if order matters, you're going to use permutation because the P has the O up here. So the permutation is when order matters. If there's like a title for president, vice president, but we don't have titles. So we're going to use a combination. We're going to pick 2 members from a club of 12. So on your calculator, I'm going to go hit math, go over to the probability, and hit enter. Oh, that didn't work. So I'm going to hit math, arrow over to the probability, and down to number 3. 12 people on the in the club, and I want to pick 2 of them. So my answer is 66. Number 10, a survey of 1,100 people in a certain city indicates that 830 own microwave ovens, 760 own DVD players, and 590 own microwave ovens and DVD players. Part A, how many people in the survey own either a microwave oven or a DVD player? Part B, how many own neither a microwave oven nor a DVD player? And part C, how many own a microwave oven and do not own a DVD player? Okay, I've drawn our Venn diagrams over to the right. Now we need to go put stuff in there. So the universal set, there were 1,100 people in the survey. So that number, I'm going to go use orange for people. All right. 1,100 is out in the universal set. All right, 830 own a microwave, 760 own a DVD player, 590 own microwaves and DVD players. So that's in here. They own both. Okay, so that was the number, what did we say, 590? Were we asked that here? How many own? Nope, we were not asked both. Okay, we need that number to find how many own microwaves. So here we go. That should be the number 830 that own microwaves. There's already 590, so I'm going to go 830 minus 590 is 240. So 240 go here. All right. Now, 760 own DVD players, so we need 760 to be in the D set. We already have 590, so 760 minus 590 is 170. So 170 will go out here. All right, how many have we accounted for? What's this number in here and in here? 240 plus 590, 240 plus 590 plus 170 gives me 1,000. And there were how many in the survey? 1,100. So that means there are 100 people not in the yellow. All right, so let's go see what we're asking for. Part A. They own either a microwave oven or a DVD player. Well, that's what's in yellow. And we've already said that that was 1,000 people. It can be in the M or it can be in the D. Okay. Let me erase that. Next, how many own neither a microwave nor a DVD player? They can't own a microwave. They can't own a DVD. So that looks to be 100. Last but not least, they own a microwave and they don't own a DVD. Okay, first thing they have to do is they own a microwave. Right there. And they can't have a DVD player. So they can't have that. So it has to be in the yellow, but it can't be scratched out. So that would be 240. Number 11. Part A. How many ways can a 4-person subcommittee be selected from a committee of 8 people? Part B. How many ways can a president, vice president, secretary, and treasurer be chosen from a committee of 8 people? All right. Part A. It says a subcommittee of 4 selected from a committee of 8. There are no titles given, so that's going to be a combination of 8. Choose 4. The calculator says that that's going to be math probability number 3. 8 people, pick 4. There are 70 ways to do that. So the answer to part A is 70. Now for part B, the number of ways a president, vice president, secretary, and treasurer, so that's 4 positions chosen from a committee of 8 people. Since there's titles given, that's going to be a permutation of 8 pick 4. So on my calculator, I have math probability number 2 is permutation 8 pick 4. 1,680. Number 12. How many ways can 4 people sit in a row of 6 chairs? Okay, so you're going to have 6 chairs. Okay, it's going to matter where Bob sits. These chairs are numbered, right? Because those chairs are numbered, and it matters if this chair is in the 6th position or if this chair is in the 3 position. That's going to be a permutation. And you're going to have 6 chairs, and you want 4 people to sit in them. So the permutation of 6 chairs, and you want 4 people to sit in those 6 chairs, you have 360 ways to do that. Number 13. A packet of sour worms contains strawberry, 4 lime, 2 black currant, 2 orange sour, and 3 green apple worms. What is the probability that Dylan will not choose a green apple sour worm? Alright, so how many of each do we have? We have 4 strawberry, we have 4 lime, we have 2 black currant, we have 2 orange, and we have 3 green apple. So how many total worms do we have? 4 plus 4 is 8, 9, 10, 11, 12, so 15 total. We want the probability that it's not a green apple. So if we add all of those up that aren't green apple, there are 12. So the probability of not green apple is going to be 12 out of 15. If we simplify that, we get 4/5. Oh, sorry, that says 4/15. 4/5. There we go. Something to point out. The probability that it's not a green apple is equal to 1 minus the probability that it is a green apple. So that's 1 minus the probability that it is a green apple is 3/15. 1 minus 3/15 is 12/15, which again is 4/5. So I wanted to point out and make sure you remember that the probability that it's not green is equal to 1 minus the probability that it is green. Number 14. A 6-sided die is rolled. What is the probability of rolling a number less than 5? So your sample space, if you roll a 6-sided die, are the numbers 1, 2, 3, 4, 5, 6. The event that you want, rolling a number less than 5, the event would be 1, 2, 3, 4. Those are the numbers that are less than 5. So you want the probability of that event. That's equal to the number of elements in that event divided by the number of elements in the sample space. So that's 1, 2, 3, 4 over 6, which simplifies to 2/3. Number 15. A box contains 10 blue cards numbered 1 through 10. List the sample space of picking 1 card from the box. So your sample space, if you have 10 cards numbered 1 through 10, is the set containing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Number 16. A card is drawn from a well-shuffled deck of 52 cards. Find the probability that the card is a red card or an 8. So the probability that it's red or that it's an 8. Well, that's equal to the probability of a red plus the probability of an 8 minus the probability of a red and 8 card. Okay, we have 52 cards in the deck. How many of those cards are red? Well, half of them are red. Half are red, half are black. So that's going to be 26 out of 52. Okay. How many of them are 8s? Well, there's 4 in each suit, so 4 out of 52 is the probability that it is an 8. All right, how many cards are red and 8? So remember, there's 4 8s. 2 of them are red and 2 of them are black. So that's minus 2 out of 52. So 26 out of 52 plus 4 out of 52 minus 2 out of 52 is going to be 28 out of 52, which simplifies to 7 over 13. Number 17. An experiment consists of rolling 2 fair dice and adding the dots on the 2 sides facing up. Using the sample space provided below, so they even give you the sample space down there, and assuming each simple event is as likely as the other, find the probability that the sum of the dots is less than 5. Okay, the sum is less than 5. 1, 1 would work. 1, 2. 1, 3. 1 plus 4 is 5, so that won't work. Nor will any of the others in that row. Okay, the next row, 2 plus 1 is less than 5. 2 plus 2 is less than 5. But the rest in that row are 5 or bigger. Next row, 3 plus 1 is less than 5. And that's it. And none of the others in row 4, 5, or 6 would be less than 5. Would have a sum less than 5. Okay, so that probability of that event, how many did we highlight? 1, 2, 3, 4, 5, 6. And there are 36 in our sample space. 6 over 36 reduces to 1/6. So the probability of getting a sum less than 5 is 1/6. Number 18. An experiment consists of rolling 2 fair dice and adding the dots on the 2 sides facing up. Use the sample space provided below, and assuming each simple event is as likely as the other, find the probability that the sum of the dots is not 2 or 5. So can't be 2, can't be 5. So what does the set look like that it is a 2? So probability, let's say the set containing a sum of 2. What does that look like? Well, that's just the 1, 1. Okay. What does the set sum of 5 look like? Let's get a different color here. Sum of 5 would be a 1, 4, a 2, 3, a 3, 2, a 4, 1. So that's the set there in pink, which is 1, 4, 2, 3, 3, 2, and 4, 1. Okay, we're wanting, what does it ask us for? Probability that the sum is not 2 or 5. So the probability that it's not 2 and it's not a 5, even though it says or, it's not 2 or 5. So really it's asking for this, 2 or 5 not, which is the same thing as not 2 and not 5. I know we didn't do any logic in this class, but that's what happens when you, lack of better words, distribute a complement over a union. You get an intersection of complements. Okay, so how many are not colored? Well, there's 1, 2, 3, 4, 5 that are colored, so that's going to be 1 minus 5 out of 36. So your answer is 31 out of 36. of that sample space, there are 31 that are not a 2 or 5. Number 19, an experiment consists of rolling 2 fair dice and adding the dots on the 2 sides facing up, using the sample space provided below and assuming each simple event is as likely as the other. Find the probability that the sum of the dots is 1. Well, first of all, how do you get a sum of 1 when you're rolling 2 dice and they both, the smallest they can have is a 1 on each of them, so the smallest sum that you can get is 2. So if you're wanting to find the probability that the sum is 1, that's an impossible event. So that probability is 0. Number 20, if 2 fair dice are thrown, what are the odds of obtaining a sum of 7? Okay, first we need to go find the probability sum of 7. Actually, I'm just going to put 7. Probability of a sum of 7. Okay, I'm going to scroll back up to my sample space. How do I get a sum of 7? So sum of 7 is down that diagonal. There are 6 ways to do that. So the probability of rolling a sum of 7 is 6 out of 36, which simplifies to 1/6. Now, the odds of that event. So I want the odds for a sum of 7. That's equal to the probability of a 7 sum over 1 minus the probability of a 7 sum. So we said the probability of rolling a sum of 7 was 1/6. So we get 1/6 over 1 minus 1/6. 1/6 over 5/6 is 1 over 5. Or we can say that the odds for are 1 to 5. Number 21, a single card is drawn from a standard 52 card deck. Let D be the event that the card drawn is a diamond. Let F be the event that the card drawn is a king. Find the indicated probability. The probability of the event D and not F. So what does that mean? It has to be a diamond and it cannot be a king. Okay, so remember for the diamonds, they all have to be of the diamond suit, and there's an ace, 2, all the way up through 10, and then there's jack, queen, king, and that's it. So I put the ace at the bottom. Alright, so there's a diamond with all of those letter and numbers on it. Alright, so you want it to be from that set, and it can't be a king. So we need to go up here to this set. If we want not F and D, we need to throw that king out. So how many cards are there? There are, let's see, 10, 11, 12 cards left. So the probability of not a king and a diamond will be 12 out of 52. And what is that simplified? 12 divided by 52 as a fraction in simplest form is 3 out of 13. Number 22, a single card is drawn from a standard 52 card deck. Let D be the event that the card drawn is a black. So D is that it's a black card. And let F be the event that the card drawn is a 3. Alright, so find the indicated probability. Probability that it's a black card or that it's not a 3 card. Using our formula, probability of D or not F is equal to the probability of D plus the probability of not F minus the probability of D and not F. All right, the probability that it is a black card, probability of D. There are 26 out of 52 cards that are black. The probability that it is not a 3, because F is that it is a 3, so not F is that it's not a 3. There are 4 number 3s, so the probability of F is 4 out of 52. So the probability of not F will be 48 out of 52. All right, now the probability that it's black and not a 3. We did one similar to that just a second ago. So the black, there's 26 of them, right? And there are 2 number 3s that are black. You need me to say that again? For the event that it's a black card, there are 26 cards there. Of those 26 cards, there are 2 that are 3s. So the number of those 26 cards that are not 3s would be 24 of the 26. So let's go do that on the calculator. 26 plus 48 minus 24. 26 plus 48 minus 24 leaves me with 50. So this would be 50 out of 52. In simplest form, 50 over 52 is 25 out of 26. Number 23. Compute the odds in favor of obtaining at least one head when a single coin is tossed 4 times. So that event, probability of that event. Okay, what is that event? So if we let the event E be at least one head, when you toss it 4 times. Okay, before we go there, let's go look at the sample space. The sample space will be, okay, so you could have, on a toss 4 times, you could have head, 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 tail, and so on. All of those different combinations until you got to tail, 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 tail. There would be 16 of those, 16 things in our sample space, because there's 2 outcomes, 2 outcomes, 2 outcomes, and 2 outcomes, and 2 to the 4th is 16. So if the event E is that there's at least one head, so that means that the number is greater than or equal to 1, then the complement of that event is that there's no heads, which would be like the number is less than 1, which would be none. Okay, so what is the probability of E complement? I guess is what I want to go after. What's the probability that there's no heads? Well, there would only be one outcome that would be no heads. It would be when you have 4 tails. So that probability of E complement would be 1 out of 16. So if the probability of E complement is 1 out of 16, then the probability of the event would be 1 minus 1/16, which is 15/16. Alright, so we want the odds in favor of at least one head, and we know the probability of at least one head is 15 out of 16. So the odds in favor of would be the probability of E over the probability of E complement. So we get 15 over 16 over 1 over 16, which is 15 to 1. So the odds in favor of would be 15 to 1. Number 24. A single card is drawn from a standard 52 card deck. Calculate the probability and odds for the following event. An ace or heart is drawn. So you want the probability of ace or heart. Well, that's the probability of an ace plus the probability of a heart minus the probability of an ace and a heart. Okay, the probability that it's an ace. There are 4 aces out of the 52 cards. The probability that it's a heart. There are 13 hearts out of the 52 cards. The probability that it's an ace and a heart. There's only one card, namely the ace of hearts, that would be an ace and a heart. So that probability is 1 out of 52. When we use our calculator, 4 plus 13 minus 1, 4 out of 52, plus 13 out of 52, minus 1 out of 52, leaves me with 4 out of 13. Now to find the odds for the event. Odds for. Odds for is the probability of the event over 1 minus the probability of the event. Probability of the event was 4 over 13 over 1 minus 4 over 13. So 4 over 13 over 9 over 13 would leave me with 4 over 9. So the odds for would be 4 to 9. Number 25. A single card is drawn from a standard 52 card deck. Find the conditional probability that the card is a diamond given that it's red. So we want the probability that it's a diamond given that it was red. So using our conditional probability formula, that's going to be the probability that it's a diamond and it's red over the probability that it's red. All right, diamond and red. So the probability of getting a red card, of the 52 cards, half of them were red, so that's 26 out of 52. Alright, now the probability of being a diamond and a red card. We just said there were 26 cards that were red, and half of those are diamonds. So that's going to be 13 out of 52. So 13 out of 52 divided by 26 out of 52 leaves you with 13 out of 26, which is 1/2. Number 26. A car agency has found daily demand to be as shown in the table. So the number of customers range from 7 to 11, and you see the respective probabilities. So it says to find the expected number of customers. The expected value of our random variable will be 7 times 0.1 plus 8 times 0.2 plus 9 times 0.4 plus 10 times 0.2 plus 11 times 0.1. just to point out, all of these probabilities are between 0 and 1, and if you add them all up, you get 1. That's what makes this an acceptable probability distribution. But now let's go calculate the expected value of our random variable on the calculator. If I type all of that in, my value I get is 9. So the expected value of our random variable is 9. Number 27. A single card is drawn from a standard 52 card deck. Find the conditional probability that the card is a club, given that it is a king. So you want the probability that it's a club, given that it's a king. Using our conditional probability formula, that's equal to the probability of a club and a king over the probability of a king. Going for the denominator first, the probability of a king. There are 4 cards out of the 52 that are kings. Okay, of those 4 cards, there's only one that is a club. Right? There's 4 kings and there's one that's a club. So the probability of being a club and a king is 1 out of 52. So the probability of a club given a king would be 1 out of 4. Number 28. Find the conditional probability in a single roll of 2 fair 6-sided dice that the sum is greater than 8, given that neither die is a 1. Alright, the probability that the sum is greater than 8, given that neither is a 1. Okay, that's going to be the probability that it's greater than 8 and there's no 1s over the probability of no 1s. Alright, let's go find the probability of no 1s first. I went ahead and gave us the sample space. There's 36 outcomes there. Okay, the probability that there's no 1s, those all have 1s, those all have 1s. So the probability of not being a 1, 1, 2, 3, 4, 5 times 1, 2, 3, 4, 5, there's 25 out of the 36 that have no 1s. Okay, for the numerator, the sum has to be greater than 8 and no 1s. So I've already scratched out all the 1s. Of those remaining 25, which ones have a sum greater than 8? So that'd be a sum of 9, 10, 11, or 12, correct? Alright, how many are highlighted there? 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 out of the 36 that have a sum greater than 8 and no 1s. Okay, so this simplifies to 10 over 25, which simplifies to 2/5. Number 29. An automobile manufacturer produces 55% of its cars at plant A. If 6% of the cars manufactured at plant A have defective emission control devices, what is the probability that one of this manufacturer's cars was manufactured at plant A and has a defective emissions control device? Okay, so you can either be manufactured at plant A or not manufactured at plant A. It says it produces 55% of its cars at plant A. So that's here. So this is going to be 0.55. Not A would be 1 minus 0.55, which is 0.45. Okay. If 6% of the cars manufactured at plant A have defective emissions control devices, so we're either going to have defective or not defective. 6% have defective, so this is 0.06. This would be 0.94. Okay, so the question, what is the probability that one of these manufacturers' cars was manufactured at plant A and has a defective emissions control device? So you're wanting to find the probability of A and defective. To do that, we just multiply the branches on the tree. So that's 0.55 times 0.06 is 0.033. Number 30, construct a frequency table and a histogram for the following data set using a class interval of width 2 starting at 0.5. Okay, so they give you all the class intervals. Now let's go put the data here in these class intervals. So starting with 6, that falls in here. Another 6. 7 falls in this class interval. 3 falls here. 2, 7, 7, 6, 9, and 6. So frequency, we have 1, 1, 4, 3, 1. How many total data points do we have? 2, 4, 6, 8, 10 data points. So if the frequency is 1 out of 10, the relative frequency would be 0.1, 0.1, 0.4, 0.3, and 0.1. How am I getting that? I'm dividing by the frequency by the number of items in the data set. So 1 out of 10, 4 out of 10, 3 out of 10, and another 1 out of 10. Now, which histogram is representative of the data above? Let's see, we need this is 5. So the scales are all the same. We need 1, 1, 4, 1, 1, 4, 3, 1. So it's that histogram. Number 31, graph the data in the following table using a bar graph. So number 31, you have groups A through G. Those are going to be down here on the x-axis. And then the revenue, okay, what graph depicts that? 238 for A. No. 238 for A. No. 238, yes. For B is 194, sure. C is 170, it's going to be a little bit less to 150, a little bit less to 139, and then down to, so I'm guessing it's C. Number 32, find the mean for the data set. Round the answer to the nearest hundredth. Okay, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 items in the data set. So I'm going to go over here to my calculator. I'm going to hit Stat and then Edit. If there's anything in my list, I'm going to arrow up and hit Clear and Enter. Now I can go put those data points in. 2, 11, 35, 2, 9, 35, 11, 9, 7, 2, 2, 2, 2, 9, 2. Okay, I put in all the data points in my list 1. I'm going to hit second quit. Then I'm going to hit stat, arrow to the right to calculate. I want to do a 1 variable statistic, so I'm going to hit enter twice, actually 3 times, 4 times. It tells me that my mean, x bar, is 9.333. Now, had I done this by hand, I would want to add all of those numbers up and divide by 15. My sample mean is 9.33. On my calculator, I have more than just that. Let's go through it. I know that my number of items was 15. My median was 7. My maximum was 35. My minimum was 2, so I could find my range by subtracting those 2. All right. Number 33, find the mean for the following grouped data. Round the answer to 1 decimal place. So it gives you the interval 5.5 to 9.5 and tells you there's 3 data points in that interval. So if you remember how to find the mean for grouped data, you need to find the midpoints of these. So the midpoints of all those intervals would be, what is that, 7.5, 11.5, 15.5, 19.5, and 23.5. Now I'm going to take the midpoint times its frequency, 3, midpoint times frequency, 1, midpoint times frequency, 5, midpoint times frequency, 7, midpoint times frequency, 4. And then I'm going to divide that number by however many data points I have. 3 plus 1 plus 5 plus 7 plus 4 is 20. So on my calculator, I went ahead and typed all the numerator in, and I'm going to hit enter, and then I'm going to divide that number by 20. So the mean of that grouped data is 17.1. Number 34, find the mean, median, and mode for the given set of ungrouped data. And how nice of them, they list it in increasing order. Okay, I'm going to go identify the modes first. Which number happens the most often? I see 3 4s and 3 5s. So it's actually bimodal. The modes are going to be 4 and 5. All right, for the middle, for the median, let's see, there's 1, 2, 3, 4 numbers I'm going to cross off. 1, 2, 3, 4 numbers I'm going to cross off. Since there's an even number of items, the median is the average of those 2 numbers, which is 4. Now to find the mean, I can add them all up and divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's what I'm going to do. I'm going to go ahead and do it by hand. So I have 1 plus 2 plus 3 plus 3 plus 4 plus 4 plus 4 plus 5 plus 5 plus 5. And I want to divide that by 10. My mean is 3.6. Number 35. Find the mean for the set of grouped data. All right, again, I need to go find the midpoints. What are the midpoints of these intervals? Between 0.5 and 2.5 is 1.5, 3.5, 5.5, and 7.5. So I'm going to do 1.5 times the frequency 5, 3.5 times the frequency 6, 5.5 times the frequency 5, and 7.5 times the frequency 2. and I'm going to divide that by the total number. If I add all the frequencies up, 5, 10, 16, 18. So n is 18. What would I get? I've added them all, the midpoints times their frequencies. I've entered those. I get 71. I divide that by 18, and I get 3.94. Number 36, find the standard deviation for the following data set: 22255668889. If you have a graphing calculator, which you should have for this class, it was on the required items, I'm going to go to my calculator, hit Stat, Edit. If there's anything in your list, arrow up and clear it out. I've already entered the 10 items, 22255668889. So now I'm going to do second quit. I'm going to hit Stat, arrow to the Calculate, one variable statistics in list 1, hit enter. My standard deviation is 2.492. I don't know how many decimal places they want. 2.49 right there. All right, that concludes the review for exam 3. Hope that helped, and best of luck on exam 3. Take care.